Alex. Good afternoon to you as well.
We are live now.
Perfect.
Hello. Can you hear me?
Yes, Alex, we can hear you.
Okay. But I don't know how
Alex?
to make my video camera.
Yeah, we are just starting, Alex. We are just starting.
Okay. Good.
Akash, my screen is visible to everyone.
Yes, sir, it is visible.
Yes.
Akash, we all are ready. And if you want us to start, we can start.
Yes, sir, we can start now. People are already joined.
Okay. Well, very good afternoon to everyone here. My name is Sanjeev Gandhi. I am running a company called Informatics. And today, in around 45 minutes time, we will be talking to you on surface metrology. Let me quickly introduce you first Geoinformatics and then my team member from France, Mr. Alex, who is also live right now. He will be also taking it over and talking to you most of the time technical applications. I want to thanks to all of you who have given us time today. I am very much aware in today's period, giving half an hour, 1 hour itself is a important thing. It's not so easy. So thank you so much. I will not take too much time on simple talking. As far as our company is concerned, some of you know us very well. We are a GIC India-based company, and the name Geo we have taken from directly. We do a lot of stuff with the inspection, a lot of things with the reverse engineering, and our company is almost now 22 years old. And of course, I'm one of the director of the company. And of course, 1995 people we are having now serving various product line. The most important slide I just want to show you here, and then I will pass on to Alex. When we say geoinformatics can do measurement, are we able to do the measurements? Unfortunately, no. We are companies which are very, very domain specific, and they are to build the solution for our customers. All these names and the domain what you are seeing, whether it's a camera-based system or a laser tracker or vision system, these are all our strength. Sorry?
Yeah, we cannot hear you clearly.
Okay. Anyway, I am passing on this thing to you. Today, we are focusing on Altimet France, which is the surface metrology company. So this is all from my side. I want to invite you to record the screen and let us start talking the real subject of it, which is the surface metrology.
Okay. Thank you, Sanjeev. So now I will share my screen, and because I've prepared a small presentation. So thank you all for being here. So my name is Alex Dembicki, and I'm the Overseas Sales and Business Development Manager for Altimet. And since 5 years now, we've got an exclusive partner in India, which is JCPL from Sanjeev. So let me introduce a little bit of Altimet. So we have started just near Switzerland, Geneva, in 2004. And we have opened now a new plant in 2012. So it's been 10 years. We are around 18 people, and we've got more than 250 worldwide customers. So as you can see, India is quite a long travel from France. So that's why we've decided to choose JCPL as our exclusive partner in India. Okay. So what does Altimet do? The activity is mainly selling standard equipment of 3D profilometer in order to measure surfaces. Because we are the manufacturer of the main technology, we can also do some upgrades of old equipment. We don't care about the brand. We can use our own electronical rack that we install in the machine. We can also do as well some measurement and rental services of the equipment. Because we are a manufacturer, we also do the maintenance. We can also deliver OEM components. So the main market is surfaces, and because surfaces, they cover everything, we've got a wide range of application. But mainly because we are just located near Switzerland, we have got the watchmakers. So this is micromechanics. If you increase the size of the micromechanics of the watch, it looks like an engine of a car. So that's why automotive and aeronautics is our second market. Then, with some research, we've decided to go also into the paper, printing, and fiduciary market, as well as the material and biotechnics. Then, you all know that the electronical components are largely increased. So that's why this is our last market, which is semiconductor and nanotechnology. How can we answer the needs for surface measurement? Is with a complete range of optical profilometer. As you can see on the slide, there is the
Yeah, Alex, I would like to stop you for a second. Like, are you moving any slides? Because, like in my screen, I can't see any moving slides. So.
Oh, yeah. And now
it's moving. Now it's moving.
The market. Which slide are you on now? You see my screen?
Yeah, I can see your screen.
And now, do you see all the different machines?
Yeah, I can see that. Now it's perfectly moving fine.
Okay, so sorry about that. So to answer the needs of the different markets, we have created a wide range of optical profilometer. And so we can start down with a small size OEM module that we can implement into the production lines. And then the thing is, we use the exact same thing. It's only the size that changes. So we go from very small to hand portable machine to machine that we can put inside a cobot or a robot. And then you've got stand-up machine like the 500, 520, 530, 560. The only differences between those machines is the size of measurement of the sample. So when it's really small, you can use either a small machine or a big machine to put many parts on the machine. Or when you've got really big samples, such as wings of a plane or the car body of a car, you can use the smallest machine that you can implement into a robot. So I go really quickly, but basically you've got 3 axes, X, Y, Z, and you implement our own technology, which is mainly confocal chromatic. So we measure the distance between the probe and the surface, and we've got nanometrical Z resolution. That's why we are really precise, really accurate on the measurement of surfaces, and that's why we are really well known in the world. Another example is this one, smaller machine implementing on a cobot. But some pictures inside a production line, on a robot, and then on a cobot at different customer sites. Our main equipment is the Altimet 500. And now, in 2 weeks, just to tell, we will be delivering this machine. It will be a demo machine for JCPL, and they will have a full range of measurement capability with full sensor, full software, and a camera. So if you've got any samples, you can send them to the team in India, and they can make some measurements. Then you've got bigger machine, and last one, biggest one for semiconductor mainly. Okay. So now let's go into the references. So this is in the watch industry. Maybe you know some of the brand. We are really well known in the automotive with Michelin or Continental for the tires measurement, as well as Renault, Delphi, NTN for mechanical parts. And we do the same for the aeronautical references, Airbus, Safran, for the engine and turbine blade measurements. We also care about the medical, and that's why we have huge brands such as L'Oreal, BASF in the chemistry, and for everything that concerns the skincare with Chanel, LVMH, or even some drugs with Pfizer. In the printing industry, we equip mainly the banks. This is in order to measure the bills and the varnish on it, the ink, as well as some huge references in museums, like Qatar National Library or Le Louvre in France. And finally, for the semiconductor, we've got huge implementation, mainly in Asia, in Singapore or Malaysia, China, with Fabtronic, UTAC, AMD, Intel. Doing this. So now, what can we really measure? So we are most known for roughness measurement. So we use the machine and the probe in order to measure different samples. and we do not care of the samples because we only need a reflection in order to being able to do the measurement. So here you can see that we've made many different profiles and we measure the roughness, so RA parameter for the profile, or because of the new norm ISO 25178 for surfaces, we do surface roughness measurement, as you can see here. So what can Altimet do? So mainly you've got some CAD and you want to do some comparison. So with the Altisurf range of machine, you can perform measurements, and this is the measurement, and you can apply it into your CAD to have the deviation of the surface compared to the perfect CAD model. So this is main thing. Then, of course, you want to do some automation. So everything Altimet proposes can be automated, and you can have directly for the operator some red or green light pass, and with an automated report that you can print. Okay, so this is good, but what kind of sample can we measure? We can measure all of them. So in the microelectronics, we can do some electronic component measurements. And for example, on this one, this is the bump and the different step heights. You can see we can really go down in nanometrical range or in millimeter range. So we can go down to approximately 2 nanometer in resolution, the Z resolution, up to 25 millimeter. It only depends on the probe that we use. For example, on this one, another electronical component, we can study the welding of the components or the height and even the roughness on all the surface. For the wafer, you can see that we've got a camera and our own sensor. We've got some options of visualization of the sample that we can rotate. Then we can do some pictures and dimensional measurement of the laser or plasma dicing. So this is just using the edge. And then we can compare it, as shown in the presentation, the width or the altitude of this crack. And we can match it, the measurement, with the picture, or even with the CAD model I've said earlier. So this is another example of diamond disc. This is in order to see if the diamond disc is used or not. Has it some wear? How long can we use it? And we can also do TTV measurements, so thickness measurements. So there is 2 ways of doing that. Either we use only one probe that do the measurement with a different technology, or we can have also 2 probes measuring upside down. For the aeronautical application, mainly we do some cracked measurement on turbine blades, for example, that we can really understand what's going on within the material that we use, and also the wear measurement. Everything that I talk at the moment is also being applied in automotive or mechanical industry. As seen in the wear measurement, we use a step height measurement for the width, and the height here is around 33 nanometer. So we are really accurate and really precise. Another example of wear measurement, but this time in 3D. and of course a corrosion measurement with a volume analysis. So how is this hole? What is its diameter, the radius, where is the center, what's the altitude or the depth of the hole? And so with all this knowledge, we can compute the volume, and we can then understand how the corrosion is being made and how it increasing within the sample. The thing that is really important now is the construction of the turbine blades for the planes, and we can set up the measurement of roughness of the small holes here, as well as the curvature of the blade. Here you've got the measurement in 2D and in 3D. I'm sorry I cannot show you all the different measurements because this is really confidential. My customer could only allow me to show you this slide. Then this is other example on this blade of the failure facies. So you can see different colors depending, so different altitude, and you can see how it behaves within the sample. So this is for the wing or the landing gear. For some different materials, you have to do some surface texturing. So this is surface texturing on a steel tube, and they are being used with a femto laser. So the first one is, this is not clean. This is just like deburring or milling, let's say. They just use the femto laser. We do some analysis, and on the curve, you can see here, we've got a peak. And after the cleaning, so they remove all the different dust made by the laser, and everything is normal again. So this way, you can really understand how to clean or to deburr or to mill, to do some different surface texturing of your surface. Because we are really near the mountains, we like to ski. So it was kind of nice of understanding how the pro ski are behaving compared to, let's say, my skis. And you can see the shape of the behind of the ski is completely different. And this allows us to do understanding how the water or the snow goes underneath the skis. Of course, now, just to show you that we can measure transparent and shaped samples, we can do some optical measurements, so with the shape and the volume of the microstructure. So we do the measurements here. You've got in 3D, and we can remove the shape in order to flatten it, and we can have either the shape for the radius measurement and also all the different holes for the microstructure. So with one measurement, you can have many kinds of analysis being possible. So this is for the form and shape. Here, this is cutting tool in order to understand how long you can use in the milling machine, like the drill. Can you use it properly? What are the different angles? Will it behave properly on the metal I drilled to? Volume measurements, once again, everything that I show you here is made in automatic. We've got a really powerful software to understand the different volumes, and that can count also the number of holes, let's say the blue holes. And we can also make some statistics behind that we can share into your different programs. This is for luxury and textile. You can have some engraving measurements, always the same, measuring the roughness, measuring the width, the depth of the different engravings. We can do also for the automotive, for the inside of the car, you can use some tissue or some laser, and you want to compare the differences. So why choose one over the other? You just make one measurement from sample 1 and sample B, and you can clearly see the differences in topography. But with this measurement, you can do lots more of analysis as roughness, step height, number of holes, and this gives you the aspect and the gloss by the end of your different material. So it's easier to choose the best one for your needs. We do also some snake skin measurements, coated textile for airbags. So is the airbag going to be good or bad? Will it hurt or harm the people when it's used? Is the coating really good on this? Same as peeling measurement and analysis. So you can see all the different fibers of the textile, and here there is a huge amount of it, so it's not good for the end user customer. So technical woven textile fault analysis. You can see we measure clearly well, and here you've got a huge hole, so there is no textile there. And you can, of course, compare it with a picture, a photography of the sample in order to understand how the fibers are behaving in your woven textile. A nice other application is paper measurement, and here we've got an example of a 16th century Chinese fibrous paper, as well as a banknote measurement. Then for the wood, because as I said earlier, surfaces cover everything, and we measure the surfaces, we can measure everything. We can have an understanding of how the varnish behave, what's its thickness. So here, an example of water varnish with its picture compared to a solvent varnish. You've got the same scale of measurement, so the comparison is really easy to make, and you can really tell that here you've got some holes or some dust, something here, and you have to decide, is it good, is it bad, depending on the plans you're trying to make. Of course, on metal, on wood, you can have some scratch measurement. On this example, this is on wood. Here you've got the step height number 1, 2. You compare it. Is it good enough? Can I clean it? Will it be easy to clean it? How come that I've got a scratch here? How can I change the parameters in my production line not to have those kind of scratches? Finally, we go into the cosmetology. We measure the human skin. You can see all the different wrinkles and veins. You can understand how they are connected to one another. But mainly, what's more important is that you can apply some anti-wrinkle cream, and you can see by the time how it's behaving. So in this one, it was the first measurement, the second one, and the third one. So this was at time 0, then at time plus 1 hour and plus 2 hours. Here you see a deep valley. It shrinkens and it shrinkens again. So that means that there is a good effect for the cream, because the valleys, so the wrinkle, is decreasing. So the altitude between the highest and the lowest point is minimal. The depth was 235 micrometer, and it goes to 100 micrometer, so 110. For the lipstick, what is the difference in coverage? But the lipstick is exactly the same as varnish. Can you tell the difference in the coverage? What's the behavior? Is it really homogeneous or heterogeneous? Everything can be done with the Altisoft machines. An example here of hair measurement for the effect of the shampoo. So you've got the hair, and then you clean it again. So you've got the differences between not clean and clean. So the effect of the shampoo is to clean this amount of material. But is it good? Is it bad? Once again, you've got to have some roughness parameters in order to do the comparison between clean and not clean hair. On this example, we've got cream thickness measurement. So there is a difference in homogeneity of the coverage. This is mainly to do the measurement of sunscreen. So if you apply sunscreen, will you get burned or not? Is the coverage good enough for you? On the top, you can see there is a good homogeneity because the valleys and the peaks are all covered. So you've got a good protection against the sun. But at the bottom, you see poor homogeneity. You see mainly different colors, mainly yellow and green. Rather on this one, it's more like bluish. We can also do some growth particle implementation in a Petri dish, just bacteria measurement. We can also measure some blood, and the viscosity of the blood has a relation to the roughness. So that's why we do it. And finally, one other is silica abrasion for toothpaste, and it depends on the different movements. So this is back and forth. So with the toothbrush, will really clean your teeth or not? That's the main issue. So I've finished now with the presentation, and I really want you to show some measurements. So I will share again my screen.
Meanwhile, I would like to say, like, if anyone have any questions, they can just put on Q&A section so we can answer them later at the end of this presentation.
Yeah, sorry, just one moment. So now I've got different machines, but as you can see, I can take control of the machines directly from the measurements. So on the right side, you've got our software, and on the left side, you've got the machines. So we've got different machines, such as this one, which is the Altisoft 500. The production and the testing. And here, this is the machine I want to show you. I've prepared a sample which is a gear for the helicopters. And now here you've got also a very small machine, hand portable. Okay. So you just need to apply or to put the sample on the stage. And with the Phoenix acquisition system, which is really easy to use, you can save some measurement protocol. So here I've made some tests. You've got different levels of users. And in the protocol, you can really follow everything. So I will just now launch it. You tap the name of the operator. Okay. So now it's moving. You will see some of the light of the sensor is applied, and we measure this line entirely. So it goes to the parking position. And now it's finished. And as you can see, automatically, here, I haven't touched anything, and you've got the report. So what have we measured? We've measured inside here the gear measurement, and it has some huge scratches. So it means that it's been wear. And the customer, they want to understand the different wear. So we've got the 3D view. Now we can go down into the analysis in 2D, and we've got the step height, and so we've got the understanding of the altitude or the depth of the scratch. I've implemented the tolerances, and is it good or is it bad? Everything can be really set up with different limits. It's really easy to use. Okay, so now this was a clear example. And what is good with the software is that you can manually change everything. So I move the profile, and you see automatically it switches itself. And now you see the scratch is not good enough. For the roughness measurement, it's quite the same thing. You just have to click some operators. So I've got many different things, but you've got a training offered with the machine. We can extract a profile. Let's say on this area. I click OK. And I go into the studies, and I've got parameter results. I click OK. And now you've got the roughness parameters. So you have to understand that Altimet is a partner of the ISO norm. So all the latest norm for the roughness, so profile or surface, have been implemented in our software, because we've got 4 development engineers that are in the norm, and they set up with the different customer in order to set up the different algorithm. And so that's why as soon as a new norm is in, you've got an update, a free update of the software to implement your measurement. Go back. So here you've got different things on the software, and the main thing is that you can move, so place different samples. You can do one measurement, and you can export it automatically. There are some other examples, but it's really easy to use, and You don't have to have like too much understanding in order to make those kind of measurements and analysis. I hope this was good for you. If you've got any questions, feel free to ask, and I will answer them now.
Okay, that was great, Alex. So I have few questions. So I'll just taking them. So I have one question from Mr. Rizvi. He's asking like, what is the least count of the machine delivered to India?
We have no machine delivered in India right now, and the first one will be for GSEPL, the demo machine, so probably in early July. But what I can show you is the list of our different academics customers.
Okay, so I have another question from Mr. Rizvi only. He is asking like how can we check the surface profile of optical lens?
So for the optical lens, it's exactly the same as in the slide I've shown. You have to focus the sensor on the lens. It will have an autofocus, so automatically it will detect transparent or non-transparent material. You make the profile, and automatically you can have the roughness or even the radius of the lens. For the lenses measurement, we've got Medicontour, Essilor, Cooper Vision, Bosch and Lomb customer. They are customer in France. And in England, Germany, Spain, as well as the United States.
Okay, I hope Mr. Rizvi got his answer. And one more question again from like he's asking, can we measure of 5 nano micron accuracy possible with this machine?
So the lowest resolution we can measure is 2 nanometer. So we can do 5 nanometer roughness measurements.
Okay, and I have another question from Mr. Sandeep. He is asking about the cost of the machine, but I would like to say, like Mr. Sandeep, we need to discuss in separate session, like what can be the cost of the machine after the custom duties, and also that will be for another part. And second question is from Mr. Amir. He is asking, what is the minimum surface roughness measurement can do for a surface? Can it do in angstrom?
No, because we have the lowest with the confocal chromatic, so our main technology, we go down to 2 nanometer. So respectively, the minimum roughness will be 5 times higher because we need to be sure that we are measuring well. So the minimum roughness that we can measure with the confocal chromatic will be 10 nanometer. Then we can also implement a different technology, which is triangulated laser, but it's not good for roughness. We can implement contact, but you can degrade. So mainly the other one, technology that we use in the interferometric measurement, and this we can measure really low roughnesses, but we do not do angstrom resolution. We have angstrom resolution of 0.5 nanometer, so 500 angstrom. But for us, we prefer to measure always 5 times higher just to be sure and to be in the metrology. So the lowest roughness measurement with confocal would be 10 nanometer, but with interferometric measurement will be around 3 nanometers.
I hope, Mr. Amir, you got your answer. So one more question I have from Mr. Sushant. Like he's asking, can we attach interferometric with Altisurf?
Just like I told you, yes. We build the machines depending on the needs of the customer. So we can choose the size of it and the volume of measurement, but also we can choose different technologies. The main technology we use is confocal chromatic, but at first, at the beginning of Altimet, it was only contact measurement. Now, we prefer not to do some scratches, not to damage the surface. So that's why we have switched to optical, but we can still have contact measurement. And we are the only company that can have both technologies of contact and non-contact. In the non-contact part, we have different technologies such as triangulated laser, confocal chromatic, white light interferometry, infrared interferometry, and that's it. Yeah.
Okay,
So,
Alex, and like I have one more question from Mr. Sushant. Can we do aspheric?
Sorry, I didn't hear you.
I have another question from Mr. Sushant. He's asking, like, can we do aspheric measurement?
Yeah. So spherical, yes. Aspherical, it will be a little bit more complicated. So as an option of the Altisurf, we have X, Y, and Z axis as standard, but you can also choose to have rotary axis in order to turn the surface in the good position or even to measure spherical components. For the aspheric measurement, we can do that, but for biggest surface, because we would need a robot or a cobot, and we can implement and follow the surface with the robot and our machine at the end of it. But what we prefer to do, for example, for the lenses, is we do a surface measurement with a really precise and open probe that can measure in the slopes as well as the shape. And with the analysis, we have an option of, again, of removing a typical formula. So if the formula is just spherical, it's really easy, but you can also implement your own formula and you can remove the form from the measurement, which is completely yours. So even if you've got helicoidal or toric, spherical, circular, or let's say other shapes, you can enter the formula of it and you can remove it from the measurement. So you will have two different measurements from one, which is the roughness. So you flatten it, and then the waviness and the shape. Is that clear?
Okay, Alex. And like I have another question from Mr. Rizvi. So he's asking, how can we get the part inspected in India? So I would like to ask Sanjeev sir to answer this question.
Okay. Geoinformatics has a complete technical center at 3 places. One is in NCR, Ghaziabad, second is in Pune, and third one is in Bangalore. So any of the three places we can do inspection. Our own machine will be coming very soon from Altimet France. So these kind of things can be done at three places in our country. Price, etc., can all be discussed from time to time. When the part is in the hand, then we can talk about the price, etc.
Okay, thank you so much, sir. And Alex, I have like a few more questions. I have a question from Mr. Govinda. He is asking, can you please elaborate on rust volume roughness measurement?
On volume and roughness measurement?
Uh, he is asking, can you please elaborate on rust volume roughness measurement?
Yeah. Sorry, there is. I couldn't hear you first because it's scratching. Your voice is scratching at the volume and roughness part. Sorry about that.
Okay, so I am repeating again. Mr. Govind is asking, can you please elaborate on rust volume roughness measurement? Am I audible to you now?
Yeah, now it's clear. Yeah, so sorry, it was with the microphone. Yeah, sorry. So the for Altimet, we do the point or line measurement. Have you seen on the example I've shown you? So the light is reflecting from the sample to the sensor, and we save all the points of measurement. So this, after that, we can make the analysis. And on the analysis, maybe I can share again my screen. I'll make it bigger. I'll just show you. So here I've opened an example of a new surface. I show you then in 3D. Okay. So here you want, let's say you want to have the volume of this. We've got what is called a study, and you've got volume either of a hole or valley depth. So I'll choose this. I can choose different things, vertical lines, square, and oops. And I need to set up the contour. And it can decide automatically. But I don't know. Usually it's made in automatic. I don't know what's going on here. Or I can choose. So you set up and you've got the valley area and everything from this. But mainly if I go to study. Then for the roughness, you go into the studies and you've got what is called parameter stable. And you've got all the different norms within the software. You choose the one you prefer. So for the surface, this is ISO 25178. You choose roughness, waviness, or even you can choose bend path. So I choose roughness. And here, I've got the 8 parameters. I click OK. Like demo mode, always the same. And here, I've got the roughness. But usually for the volume, For the volume, you've got to set up a huge square. Sorry. You choose least square plan, and then it will perfectly fit. And here you've got the holes in red and the peak in green. So what you have to do is just make the measurement with the machine and then do the analysis, and automatically you can have the different parameters of roughness or volume or even sphericity here on the bearing. You go into the studies, you go into the contour analysis, you set up the circular, you click into knowing, and here you've got the radius. Is it good answer?
Okay, I hope Mr. Govinda got his answer. Okay, so I have one last question from Mr. Rizvi only. He is asking like how is it different from tactile measurement?
So we are mainly known for roughness measurement. So the range of tactile measurement for us goes to the nanometer range to approximately 2.5 millimeter. We do contour for small parts, but for contour, there is specific equipment that Altimet does not provide. And the difference is the length of the arm and also the resolution for the contour. So basically, contour is a different machine that Altimet can produce, because Altimet mainly does surface measurement, and it's in surface measurement, it's mainly topography, so for step height and roughness. The tactile was only at first to do roughness measurement. We can do little contour if you are in the range of the 2.5 millimeter or less.
Okay, I hope Mr. Rizvi got his answer. And I have one more question from Mr. Like he's asking what is the repeatability of this equipment as is non-contact type?
Okay. So this I've got. So the repeatability really depends on the probe you use, because it's the probe that does everything. And on the screen that I will share once again. Sorry for being long. If I zoom in here, so it was a really low roughness measurement of 1.5, and you can see that we've got a really low standard deviation. So mainly the repeatability will be in percentage of the range of measurement, and it is about 0.001% of the range of measurement. So we've got a standard deviation always in angstrom. For this, I will refer to the sales team of JPSL, and I will give them all the different data sheets of our machines that you can see here.
Okay, we are like done with the questions now, and now it's time to end this webinar. Thank you so much, Alex, for this wonderful presentation. So I think everyone got an idea about Ultimate and its product. So thank you again very much, Alex, and thanks everyone for joining today's webinar. And to see you again in another wonderful webinar. Thank you for joining today.
Yeah. Thank you so much.
Thank you, Alex.